everybody, like I said in the last video, this video is going to be about the distributive property. So what is the distributive property? Let's dive in. The distributive property states that when multiplying a number by a sum, we can first 1. Add, then multiply, or 2. Multiply, then add. What does that mean? Well, let's see. If A times by the sum of B and C is also equal to A times B plus A times C. The same thing applies to if you're subtracting too, but Jaws, that sounds so weird, right? It says a sum. Well, subtracting is the same thing as taking the sum of a positive number and a negative number, so it also applies for subtracting. This is just the weird vernacular for it. So let's try some. Let's rewrite these expressions. Remember we learned about expressions? There's no equal sign here. Expression. So we're going to rewrite this as, first, we're going to distribute the 4 to the x. So that's 4x, with 4 being the coefficient. Oh, look at all these new vocab words. Then we're going to distribute the 4 to the 3. Keep the plus. 4 times 3 is 12. Good, let's do it again, except with this whole value. Distribute the whole negative 3x to the y equals negative 3xy. A negative times a negative is now a positive. Negative 3x times negative 4 is equal to positive 12x. Great. Next, we're going to do A times 4b. A times 4b is equal to 4ab. A times positive 3c plus 3ac. And last, A times a negative d minus ad. So here are some of our distributive property expressions examples. Now the next thing we're going to talk about, which is kind of related here, is factoring and like terms. What does like terms mean? Like terms are the terms whose variables are the same. Sounds pretty simple. For example, 3y and 23y are like terms because they both have a y. 4x squared and negative 7x squared are both like terms because they both have x squares. However, it's okay that this has a negative and this is a positive. And 11 and 8, both like terms. They both have no variables. Not like terms. 7a cubed and negative 8a to the 5th. They're not like because of the negative and positive, as this example over here showed. Rather, they're not like because a to the 5th is raised to a different power than a to the 3rd. Then 11y squared is different than 5x squared because this is a y squared and this is an x squared. Here is an example. What are we going to do with like terms? Well, we're going to combine them. So 4x plus 5x minus 7, we're going to combine the 4 and 5x into a 9x. Then we're going to take over here. Also, here's something to know. I'm going to mention this probably throughout the next few videos. Something that I like to call, and I tell my students in person this too, secret ones. Secret ones are very important. Secret ones are everywhere. We actually discussed this when we were talking about the fractions before. In a few videos back when we were just adding, say, 2/3 or multiplying 2/3 times 3, there is a secret one that's in the denominator. We also have secret ones with distributive properties. A secret one in front of here. We're now going to distribute the negative to here and the negative 1 to here to rewrite this as, let me just change color so you guys can see that, a minus negative 1 times 4a, negative 4a. Negative 1 times negative 5 plus 5. There are secret ones everywhere, guys. So now back to what we were talking about, like terms. We're going to combine like terms. A and negative 4a are like terms to go to negative 3a. Now we're going to keep the 5. Factoring. What is factoring? Factoring is basically the reverse of multiplying. We have to find an expression equivalent to the original product. This is kind of like undoing a distributive property, for example. So AB plus AC is going to equal A times B plus C. Oh wait, doesn't this look a lot similar to what we're talking about? That's because it is, guys. I actually just copied the original text because Undoing a distributive property is done by factoring. Factoring is undone by using the distributive property. So again, AB minus AC is equal to A times B minus C. Again, sums, differences, doesn't make a difference because a difference is just a sum with a negative number. Let's evaluate some of these expressions. Expressions, not equations, because they don't have an equal sign. First, what are we going to do? Oh, we have like terms. We have a C and we have a C. Let's combine these like terms. 7C plus 5C, 12C. Keep the 10D because we have nothing to add it to. Next, we have a 6. Oh my gosh, we have a secret 1. So we're going to transfer this negative 1 to each of them via distributive property. So now we have 6A minus a 4A minus a 3. Now we're going to have 6A and 4A are like terms. 2A minus 3. Great. X minus 9x. Oh, x and 9x are like terms. So now we're just going to have negative 8x. Let's keep going, burning right through this. We have the like terms of 9y and negative y. Then we have the like terms of 10z and negative 6z. So 9y minus y, 8y. 10z minus 60 is a positive 4z. Last, this has a bunch of steps. So first we're going to do distributive property. Here and here. Then we're going to do it here and here. Let's break this down into 2 different colors so we can, oops, I erased the y. So we can keep track of everything we're doing. Go back. Sorry. So first we're going to do the 9 part. So over here, negative 9 times y, we're going to have a negative 9y. Then negative 9 times a positive 7, negative 63. Now over here, we're going to have negative 6, whole thing. Negative 6 times y, negative 6y, negative 6 times negative 3, positive 18. Next thing we need to do, combine like terms. Negative 9y, negative 6y are like terms. Now we have negative 15y. Negative 63 and 18 are like terms. Ooh, what is that? Hold on. 63 is minus 18. This will be a minus. Then we have 5. 45, does that look about right? Yes, minus 45. Just for giggles, how would we factor this out? Oh, I have an idea. We factor kind of by using the GCF that we learned about before. So what would be the GCF of the 2 terms in this expression? Negative 15. Negative 15, if we pull it out to factor it, we would have inside left y plus 3. This whole part is equivalent to this whole part, which is equivalent to this whole part. To get here, we had to use the distributive property, and we also had to combine like terms. Then to get here, we just went and factored again by using what we learned in a few lessons ago, the GCF. So here back, we can look at this, and we can say we can factor by using the GCF. Hope this makes a little bit more sense to you guys. Tune in for the next video.